And this is example 6, and we're going to be looking at Pythagoras Theorem again. We have a thin steel tower is supported on one side by 2 cables. Find the height of the tower and the length of the longer cable. Okay, so this is our picture. The base is 25. This is the tower here in dark black, and we need to find the height of the tower and the length of the longer cable. So we need to find this length here and the height of the tower. So let's call this B first, this length down here. So this is length B. So we have B, A, and C. So this is our first triangle. We need to find this length first. So we have Pythagoras for the first triangle. We have A squared plus B squared equals C squared. A here is 25. So 25 squared plus B squared equals C squared, and C here is 40. 40 squared. Okay, so 25 squared is 625 plus B squared equals 40 squared. That's 1600. Okay, so B squared will be 1600 minus 625, and that's going to give us 975. And B will be the square root of that number, 31.22 meters. Okay, so this length here is 31.22. Okay, so we found the height of the tower. The height would be 31.22 plus 10. So we get 41.22 meters. Okay, that's the first bit there. Now we need to find the length of the cable. So we have to do Pythagoras again. But now A, we can call this, well, let's call that A here, 25, as before. B is going to be the height, which is 41.22 squared equals the length. Now we don't know that length, so let's call that C. Let's call that C squared. So 25 squared, that's going to be 625 again. And when we add the 41.22 squared, we're going to get 2324.09. That's C squared. So let's just do the total. And so C, the length, is going to be the square root of that number. It's going to be 48.21. meters, and that's the length of the cable here. Okay, so that's the value of C, and then the height of the total height of the tower is 41.22. In this question, we want to find the area of an equilateral triangle that has sides of each length 8 centimeter. So we could probably start with the picture. Equilateral triangle. Okay, equilateral triangle, all the sides are the same length. In this case, they're 8 each. So we've got 8, 8, and 8 down here. Now if we drew the line down the center, it will bisect this line here. So these each will be the same length. So if the total is 8, one side of that is going to be 4. Okay, so as we want the area of this triangle, we need to find the height of the triangle here. This is a right angle. So let's call that A. And we can apply our Pythagoras to this triangle here. Okay, so we'd have A squared plus B squared, which is 4 squared, equals 8 squared. So we're going to have A squared plus 4 4s is 16 equals 8 8 64. Okay, so move the 16 over, or subtract 16 both sides. We'll get 64 minus 16. A squared will equal 48. Okay, we can simplify this a bit more. A will be root 48, and it's probably better to write that as 4 root 3. We could use a decimal, but we don't need to here. Okay, so for the area is half times the base times the height. Just the normal formula for area of a triangle. Half the base is 8. Don't use the 4, use the whole base. Total base is 8 times the height, which is 4 root 3. Okay, you can see here 2 and 8 will cancel to 4. So we get 4 times 4 root 3. So our area is going to be 16 root 3 square centimeters. Okay, and we can write that in decimal form, 27.71 cm squared. Okay, so that's the area of an equilateral triangle. Just use that method. Okay, this is example 8. So similar to the last question, except we have an isosceles triangle, and we want to find the side length here, x. Okay, the height of the triangle is 24, the base is 20. Okay, in this picture, this is a right angle, and this line will also bisect this. So these two lengths are equal. Okay, so if the total is 20, each side is 10 each. Okay, so we've got a triangle there, which looks basically like this. We have this side, which is 24, that's the height, and 1/2 of the base is 10, and this is x, and at the base here we have a right angle. So let's use our Pythagoras here. We'll end up with 24 squared plus 10 squared equals x squared. Okay, 24 squared is 576 plus 100 equals x squared. So we have 676 equals x squared, and x will be square root of 676, that will be 26 cm. Okay, so that's the length of the side, and that will be on both sides. So this will be 26, and being isosceles, this will also be 26, and the base here is 20. Okay, this is example 9. We have another triangle, actually two triangles, two right angled triangles here and here, and we want to find the length of CD or DC and the perimeter of the whole triangle, okay, and also the area of the triangle. So what I would do here, to find this length here, we actually need to know this length here. So I'm going to call that B. I'm going to call this length here A. Okay, so first thing I want to do is find B from this triangle here. So use Pythagoras again. So this will be part A. So we need to find B first. So we'll have 16 squared plus B squared equals 20 squared. Okay, 16 squared, 256, plus B squared equals 400. Let's rearrange. B squared would be 144. So we can see B here is going to be 12. So this length here is 12. Okay, now we can use that length and 13 to find A. So let's continue. So in the second part we'll have 12 squared plus A squared equals 13 squared. When we rearrange, A squared will be 25 and A will equal 5. And these are all cm, so we should write that down. Okay, so the length of CD is going to be 5 centimeters. We could write that there. So 5 centimeters. Part B, the perimeter. So what do we got? Total length around the outside. So 20 plus 13 plus 16 plus A, which is DC, that's 5. Okay, so what would be the total length then? We've got 54 for the total perimeter of the triangle. Okay, part C is the area. And the formula for area of triangle is half times the base. So 16 plus 5, that's going to be 21. Times the height, which was part B, which was 12. When you multiply them all up and simplify, you'll get 126 cm squared. Okay, that's how you find the area.